We will be learning about connection pooling. It is one of the important topic in databases. So connection pooling. So let's say whenever we are having an application and that application needs to query the database, what happens here? Initially, it does some. It makes first TCP handshake and then it does SSL negotiation and some authentication memory allocation, and then our single connection is established. A connection is established means like memory allocation and authentication, like we have some memory allocated in the database machine so that it can query, it can use it for our query, something like that. So it runs good, okay, it's well and okay for one query. Let's say we are having 10 queries. So for every, for like for all 10 queries, if we want to make each new connection each time, what will happen? Yeah, simply latency will increase. Let's say initially we made some 10 connections and didn't close them, and whenever our app tries to query the database, we'll use one of the connection in the from those 10 connections, and like this after the usage we can leave that connection. So concurrently now many requests can go to the database concurrently. So this is what we call it as connection pooling. So if we see, let me decrease it. Let's say uh, without pooling, what happens? Without pooling, what happens? An approximate time for opening a connection will be approximately 30 milliseconds. And let's say for the query execution, it took 5 seconds. Sorry, 5 milliseconds, let's say. And closing the connection is also a 5 milliseconds. This is without pooling. So this is for one request, that is around 40 milliseconds. Let's say we have 10 queries, or for 10 requests. For 10 requests, it is 400 milliseconds. Now let's see with query, with pooling. Let's say we made a pool of 5 connections. So for opening all those 5 connections, how much time will take? Approximately 30 into 5, it's 150 milliseconds. For query execution, it is same, 5 milliseconds into 10. It is around 50 milliseconds. Closing connections, it is around 50 milliseconds. Now if we see here, time will be 150 plus 100, it's around 350 milliseconds. So here we can see a small difference. Here, because here the connections are only 5 and the requests are only 10. So in the long scale, if there will be many requests coming. In that case, it's obviously like almost 100 times faster. We can make it as 100 times faster, or it depends on what we are making. Most probably we can decrease it to tenfold, and if possible we can make it to 100 times, and it's unlimited number of times provided you are having the resources. That's it. So generally how it works: first we will initialize a pool. Initialize a pool. So let's say we created n connections. Next, what we will do. So it's not mandatory to create n connections in the beginning only. We can create it like as the requests are coming. That might save us some time, because sometimes let's say we made uh, 10 connections, and the maximum number of requests coming per second, let's say 5. Creating 10 connections, but only 5 of them are being used. So here we are having 5 unnecessary connections. So that is also one method, like creating the connections as the requests are coming. And initially at the startup only we can create 10 connections, and we can close the connections based on their ideality and maximum on time, all those things. So it depends on the uh, development of that pool. So now whenever a request comes, we'll borrow a connection. If available, it will provide one, else it will be in the queue. Next, execute query, and then return connection. Return the connection. This returning the connection part is very important, because let's say if the connection is not returned, the connection leak will happen, and whole the what you say, the pool will be busy, and all the requests club together, and the queue will be large, and the site will be crashed, or else the database queries will be like crashed. That's it. So if we see general pool connection, minimum pool size in real life, like wherever software we are using, it will be 5 to 10 we can use. This will be warm pool, because most of the time all the 10 connections will be used up. It is called warm pool. And now we keep max pool size. If we say this, there is some 20 to 200. 20 to 100. Ideally we can create 1000 n number of connections, but there comes some limitation. We'll talk about it. So this is for maximum concurrent connections. Now next thing we shall discuss is connection timeout. What is connection timeout? So let's say uh, we are having the connection pool, and at the startup time, not when every connection is started. Let's say only 2 connections are started. Now third connection is needs to be established. So the third request came, the third connection is establishing. So if this connection time, this is what we are calling as connection time. So generally it will be around 30 seconds. So if the connection is not established within 30 seconds, we'll send to the user, I mean the client, connection timeout error. So that request will not be queried, like processed. So idle timeout. This idle timeout is for what we call it is for connections only. Let's say a connection is there and no request is being processed by that connection for a certain period of time. That is what we call it as idle timeout. It stays still. This will be generally around 10 to 30 minutes. Now if we see max lifetime of a connection. Once a connection is established, there's the amount of time that it cannot be closed. Maximum lifetime. And that is what we call it as max lifetime. It will be generally set to 30 to 60 minutes. Let's say even though that connection is, let's say there is a connection and it is getting continuously requests for 1 hour. What happens is that, let's say we set max lifetime as 1 hour. So at that point of time, that connection will be closed and again it will be restarted. So this is what We call it as recycle connections to prevent stale state. Now if we see popular tools, one is PG Bouncer. We can see here. Uh, Here you can see here. PG Bouncer is something like it runs on, most probably it runs on database only, but it is some different OS process, not whatever the Postgres process is running. It is different OS process. It's one more kind of application thing. It is what maintains the connection pool. And so before hitting the Postgres, we will hit the like our request go through PG Bouncer. And there are many other tools for MySQL. There is Proxy SQL, and this is what PG Bouncer is kind of database side connection pool framework. There can be client side connection pools also. Uh, it depends on the framework we are using. We can create a connection pool from the app also. That is one thing. And let's have something. Let's say we are creating a new DB connection. Why is it expensive? It's obviously a TCP handshake and authentication and memory allocation on the both devices for that request. What happens if we set a maximal size too high with many app servers? What happens? Database runs out of connections. So this is a very important topic. I mean, very important point. Let's say if we set pool size very high, uh, in each of let's say we set pool size as very high, let's say 100 connections. From each app you will be getting 100 connections. Let's say everything is on its highest traffic, so 100 connections, and let's say there are 100 apps connecting to the database. Total you will be having 10,000 concurrent connections. And obviously most databases, normal databases, will be failing at that point. So there is a limit from the database side also to the maximum number of connections that it can have, so that should not exceed. So keep that in mind, and we should design based on that part. So thank you for this seeing this video. Thank you.